In this video, let's try and understand what are finite state machines and their types. A finite state machines is a 5-tuple mathematical models of computation which is defined like M is equal to Q. Q stands for the finite set of the state and sigma stands for finite. Sigma stands for finite input alphabets. Delta is a transition. So for the states, the input alphabet is given. There is a state transition. So this represents a state transition function. Q0 is the initial state and F is the final state. Finite state machines, or we can call it as FSMs, are used to model sequential logic, language recognitions and control systems. So there are different types of finite state machines. The first one is the deterministic finite state machines. Here each state and input there is exactly one transitions. Easy to implement and there are no ambiguity. Non-deterministic finite state machine, a state and the input may have multiple possible transitions, equivalent in power to DFA but simpler to design. Epsilon NFA is a transition allows on empty strings as well. Without consuming any input also we should be able to make a transitions. Convenient for language representations, can be converted into DFA. So these are the different comparisons of DFA, NFA and Epsilon NFA. So these are the features: transition function, start state, accepting states, easy of implementations, expressive power. So coming to the DFA, exactly one for each symbol from each states. So there are no ambiguity. So with one input there is exactly one transitions. In NFA, that is non-deterministic, we can have 0 or more for a symbol or 0 or more transition with the same input. Epsilon NFA can have 0 or more or epsilon transition. There is no transitions also. So here is a transition functions. You have a delta which is equal to Q into sigma, which will give you a definite, definite transitions. Whereas here is a delta transitions, you have Q into sigma into 2 to the power of Q transitions. So these are the different transitions it can have. Similar fashions here, delta transition is equal to Q into input sigma union without any strings also we should be able to make a transitions which is equivalent to 2 to the power of Q transition state. Okay, so start state is single. Accepting state is a subset of a finite state, subset of a states. Easy of implementation, easy. Actually for students DFA they might find it difficult. NFA is very simple and Epsilon NFA is also kind of easy, but to represent it looks complex. But designing to draw, so NFA and Epsilon NFAs are easy, but representation would look, the implementation would look for NFA and Epsilon NFA. Expressive power, it is all same for DFA, NFA and Epsilon NFA. All of these are equivalent. The key takeaways of this session is FSMs are represented as a mathematical model using 5 tuples. That is Q, total number of state, sigma is the alphabet, delta is a transition, Q0 is the initial state, F is the final state. DFA deterministic and there are no ambiguity. NFA is non-deterministic and it has got multiple choices. And Epsilon NFAs allow empty transitions as well. All three are equivalent in power, expressive powers and can be recognized as regular languages. Thank you. Watch next videos for problems on NFA, DFA and Epsilon NFA. Thank you.